This presentation covers Chapter 11, Light, Reflection, and Refraction. CBSE Class 10, Physics. Slide 2, Index. This presentation covers an extensive list of topics, including reflection of light, spherical mirrors, the mirror formula, refraction of light, spherical lenses, and the lens formula. Reflection of light. Let's begin with a few important definitions. Light. Light is an electromagnetic ray that travels in a straight line. Reflection. When light falls on a surface and is reflected back into the same medium. Refraction. When light travels from one medium to another and bends from its original path. Terms related to the reflection of light. Here are some important terms you should know. Incident ray, the ray that strikes the surface. Reflected ray, the ray that bounces off the surface. Normal, a line perpendicular to the surface at the point of incidence. Angle of incidence, the angle between the incident ray and the normal. More reflection terms. Angle of reflection, the angle between the reflected ray and the normal. Object, the source of light or the thing being reflected. Image, the appearance or reproduction of the object formed after reflection. Virtual image cannot be captured on a screen. Real image can be captured on a screen. Laws of reflection. There are three laws of reflection. The angle of incidence is equal to the angle of reflection. The incident ray, reflected ray, and the normal all lie in the same plane. The incident and reflected rays are on opposite sides of the normal. Properties of plane mirror. Images. A plane mirror forms images that are virtual and upright, same size as the object. Same distance behind the mirror as the object is in front. Laterally inverted, left appears right. Types of spherical mirrors. There are two types of spherical mirrors. Concave mirror, reflecting surface curved inward. Convex mirror, reflecting surface curved outward. Spherical mirror terminology. Center of curvature. C. Center of the sphere of which the mirror is a part. Radius of curvature. Distance from center of curvature to the mirror. Pole. P. Center of the mirror's surface. Principal axis, straight line through the center of curvature and pole. Principal focus. Focus of concave mirror. It is a point on the principal axis, where all the rays parallel to the principal axis converge. Focus of convex mirror. It is a point on the principal axis, where the reflected rays appear to converge. Focal length. The focal length is the distance between the pole and the principal focus. Note, radius of curvature equals 2 times focal length. Rule 1 for reflection from spherical mirrors. A ray of light that is parallel to the principal axis, after reflection, will pass through the principal focus in the case of a concave mirror, or appear to diverge from the principal focus in the case of a convex mirror. Rule 2 for reflection from spherical mirrors. A ray passing through the principal focus of a concave mirror, or a ray directed towards the principal focus of a convex mirror, will emerge parallel to the principal axis after reflection. Rule 3 for reflection from spherical mirrors. A ray passing through the center of curvature of a spherical mirror is reflected back along the same path after reflecting. Rule 4 for reflection from spherical mirrors. A ray incident obliquely to the principal axis towards the pole of a spherical mirror is reflected back obliquely, following the laws of reflection, where the angle of incidence equals the angle of reflection. Image formation by concave mirrors. Part 1. Object at infinity. The image is formed at the focus F, is highly diminished, point-sized, and is real and inverted. Object beyond C. The image is formed between the focus F and the center of curvature. C is diminished and is real and inverted. Image formation by concave mirrors. Part 2. Object at C. The image is formed at C is the same size as the object and is real and inverted. Object between C and F. The image is formed beyond C is magnified and is real and inverted. Image formation by concave mirrors. Part 3. Object at F. The image is formed at infinity, is highly magnified and is real and inverted. Object between F and P. The image is formed behind the mirror, is magnified and is virtual and direct. Summary of images formed by a concave mirror. This slide provides a table summarizing the position, size, and nature of the image formed by a concave mirror for different positions of the object. Image formation by convex mirrors. Object at infinity. The image is formed at the focus, F behind the mirror, is highly diminished, point-sized, and is virtual and erect. Object between infinity and pole P. The image is formed between the pole, P, and the focus, F behind the mirror, is diminished and is virtual and erect. Uses of concave mirrors. Concave mirrors are used in shaving mirrors, torches, searchlights, and vehicle headlights, by dentists to get large images of patients' teeth, in solar furnaces to concentrate heat. Uses of convex mirrors. Convex mirrors are used in vehicles as rear view mirrors to see traffic at the rear side, as a device to check for theft in shops. New Cartesian sign convention. According to the new Cartesian sign convention, the object is placed to the left of the mirror, and the pole is treated as the origin. Distances to the right of the origin are positive, and distances to the left are negative. Distances above the principal axis are positive, and distances below are negative. Mirror formula. The relationship between the object distance, u, image distance, v, and focal length, f, of a spherical mirror is given by the mirror formula. 1 divided by v plus 1 divided by u equals 1 divided by f, where u is the object distance, v is the image distance, and f is the focal length. Magnification. Magnification m produced by a spherical mirror is given by the ratio of the height of the image to the height of the object. It is also related to the image and object distances. The formula is m equals height of the image divided by height of the object, which also equals negative v divided by u. If m is positive, the image is virtual and erect. If m is negative, the image is real and inverted. If the absolute value of m is greater than 1, the image is bigger than the object. If m equals 1, the image is the same size as the object. If the absolute value of m is less than 1, the image is smaller than the object. Refraction of light. Refraction is the phenomenon of the bending of light when it travels from one medium to another. Laws of refraction. The incident ray, the normal, and the refracted ray all lie in the same plane. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant, known as the refractive index. This is also called Snell's law. Refractive index. The refractive index of a medium indicates its light bending ability. The refractive index of medium 2 with respect to medium 1 is given by the formula speed of light in medium 1 divided by speed of light in medium 2. The absolute refractive index of a medium is given by speed of light in air divided by speed of light in the medium. Refractive index table. This slide provides a table listing the absolute refractive index values for various materials, such as air 1.0003, water 1.33, crown glass 1.52, and diamond 2.42. Refraction by spherical lenses. There are two main types of spherical lenses. Convex lens, a lens that is thicker at the center and converges parallel light rays. Concave lens, a lens that is thinner at the center and diverges parallel light rays. Important terms for lenses. Optical center, the center point of a lens. Principal axis, a line passing through the optical center and the centers of curvature of the lens surfaces. Focus, the point where rays parallel to the principal axis converge for a convex lens or appear to diverge from for a concave lens after refraction. Focal length, the distance between the optical center and the principal focus. Rule 1 for drawing ray diagrams for lenses. A ray of light that is parallel to the principal axis, after refraction through the lens, passes through the principal focus for a convex lens, or appears to diverge from the principal focus for a concave lens. Rule 2 for drawing ray diagrams for lenses. A ray of light passing through the principal focus for a convex lens or directed towards the principal focus for a concave lens focus for a concave lens will emerge parallel to the principal axis after refraction. Rule 3 for drawing ray diagrams for lenses. A ray of light passing through the optical center of a lens will go straight without any deviation. Image formation by convex lens. Part 1. Object between O and F. The image is formed behind the object on the same side, is magnified, and is virtual and erect. Object between F and 2F. The image is formed beyond 2F, is magnified, and is real and inverted. Image formation by convex lens. Part 2. Object at infinity. The image is formed at the focus, F, is highly diminished and is real and inverted. Object beyond 2F. The image is formed between F and 2F, is diminished and is real and inverted. Image formation by convex lens. Part 3. Object at F. The image is formed at infinity, is highly enlarged, and is real and inverted. Object at 2F. The image is formed at 2F, is the same size as the object, and is real and inverted. Image formation by concave lens. Object at infinity. The image is formed at the focus F1, is highly diminished and is virtual and erect. Object between infinity and O. The image is formed between the focus F1 and the optical center O, is diminished and is virtual and erect. Sign conventions for lenses. The sign conventions for lenses are the same as for spherical mirrors, but all distances are measured from the optical center. Distances to the right are positive, to the left are negative. Distances above the principal axis are positive, below are negative. Lens formula and magnification. Lens formula, the relationship between object distance u, image distance v, and focal length f is given by 1 divided by v minus 1 divided by u equals 1 divided by f. Magnification m, the ratio of the height of the image to the height of the object. The formula is m equals image height divided by object height. which also equals V divided by U. Power of a lens. The power of a lens is the reciprocal of its focal length. The formula is P equals 1 divided by F. The SI unit for the power of a lens is the diopter D. Thanks for learning with us.